Hello wonderful person, this is Anton, and this is the so-called C2019 Borisov Comet. This is the second interstellar comet we discovered only in August of 2019, and we already have several papers discussing not just what it's possibly made out of, but also where it possibly came from. Today, let's talk about what we've learned so far about this unusual comet, and welcome to What the Math. So I've actually tried to contact the discoverer of this comet, and he is unfortunately super busy, so he wasn't able to answer too many questions. But I'm going to try to reach out to him and possibly even make a video about him sometime in the future. For now, let's focus on the science of what we know about this comet and what we think is on the surface and possibly where it came from. So first of all, in the last few weeks, at least one study came out predicting its path in the past and discovering where this unusual object may have come from. What the Polish scientists from the paper that you can find in the description below discovered is that it has a very high chance of coming from a nearby red dwarf binary system known as Kruger-60. Kruger-60 system is actually somewhere right there, but because these are red dwarfs, they're extremely difficult to find. They're very difficult to see. Both stars are not very massive. They're only a fraction of the mass of the sun, and so they don't really produce as much light as a typical star. And these two red dwarfs, this one here is the larger one, only about 27 or so masses of the sun, orbit around one another at a distance of just over 9 astronomical units. That's the distance of Saturn to the Sun. Its partner here, the Kruger-60b, is even smaller. It's only about 18% of the mass of the Sun. And as they orbit around one another, let's actually take a look at the orbit from a distance, they have a tendency to disrupt various bodies in the system, if there are any bodies here. And because it's a binary system, due to the interaction between two bodies, the third body here, specifically, for example, a planet or a comet, would not really have a very good chance of staying in a stable orbit. In other words, there is a very high chance that this comet may have been kicked out of the system because there are two stars here. Now, how do they know it came from here? Well, by studying the trajectory of Borisov, and by looking back at where it may have come from, and also estimating the velocity of Borisov Comet when it was in that location, the scientists behind this paper were able to figure out that approximately 1 million years ago, the comet known as C2019 Borisov passed within about 5 to maybe 6 light years away from the star system known as Kruger-60. And it didn't just pass close to that system. The actual speed of passage was only about 3.5 kilometers per second, which is actually really low. It's a similar speed to what you would expect from an object that was just kicked out of a star system. In other words, there's a very high chance that it actually did come from the system, because these are the speeds we expect from an object that was basically a comet that was kicked out. And interestingly, the system is actually slowly moving closer to our sun, and within about 88,000 years from today, it's going to come pretty close, within about 6 light years away from us. So it's going to become one of the closest binary stars to us within the next 88,000 years. But right now, it's still a little bit farther than that. It's about 13 light years away from us, so even though it is close, it's not the closest. And this is actually a very interesting discovery, because in contrast to Oumuamua that we found back in 2017, we have never been able to pinpoint where this came from. It sort of came from the direction of a very bright star known as Vega, but we know that it didn't come from Vega itself, and we couldn't really pinpoint the direct location. But there are obviously other things we've learned as well, specifically things related to chemistry, and this is the most important thing, because we would like to learn more about these different stars out there by studying objects coming from them. So in the last few, weeks, or technically months, we've also identified several molecules that are emitted by the comet. It's actually a little bit easier to see these emissions if we change the light here a little bit. So these emissions, for the most part, are relatively similar to typical comets we find coming from the location of Jupiter. So in other words, it's similar to what's known as Jupiter family comets, with one of the more famous one being this one right here that's about to collide with Jupiter. This is the Shoemaker-Levy that we got to observe colliding with Jupiter back in 1994. So in general, all of these comets sort of share similar composition, and they also have a very unusual lack of carbon. There are quite a lot of carbon-depleted comets out there. The most famous example is the comet known as Halley, that was last seen in 1986, but will actually come back and reappear in the night skies in 2061. And in all of these comets, for the most part, all of this carbon that's missing is usually emitted in the tails that we get to see later on. We've actually discovered all of this quite a long time ago, and there's at least one paper you can read where this is discussed in a lot more detail. The paper right here from 1988 that you can read, and it's also in the description below. And so by looking at the emissions from the comet Borisov, the scientists discovered that the emissions were very similar to the comets we get here in the solar system. And so as of October of 2019, we've discovered hydrogen cyanide, which is the HCN molecule, and the molecule that's most likely acetylene, which is the C2 molecule. The study that discusses in a little bit more detail is also in the description below, but all of this of course suggests that this particular comet is technically no different from comets that we get here in the solar system, with one of course major exception, the age. If this star system that it came from is a lot older than our own solar system, we'll be able to identify this in some of the other future studies. And so if we look at the material coming from that particular comet and discover that it kind of matches the age of this system here, Kruger 60, it will be a definitive sign to us that it probably came from here. Right now we're not entirely sure how old this system is, but there's a very big chance that it will help us understand how these systems evolve and of course how the materials in these systems is different or similar to our own. But most importantly, it just so happens that one of these stars in this system is what's known as a flare star. This object here is basically a star that flares up quite a lot. It has a lot of very energetic emissions, and once in a while it produces more energy than even our sun. And because it's a flare star, we've always speculated that it would be pretty dangerous to live around such a star. And so if the comet did come from here, and if we're actually able to identify the effects of these flares on this comet, it will help us to see if it's actually as dangerous as we thought, or if it's something that both this comet and potential planets in the system can actually survive. In other words, we are kind of curious to discover if these flare stars are so powerful that they're able to destroy atmospheres of various planets, or if it's possible to one day discover a habitable world around them. Because it just so happens that the closest flare star to us is the super famous Proxima Centauri. The star that you see right here with a beautiful Proxima Centauri B planet that just so happens is right there in the habitable zone. So understanding how these flares affect these comets and these planets is going to be really important for us to study for the future of humanity and for the future of space exploration. But for now, that's all we'll learn about this comet as of October of 2019. I'm sure there's going to be a lot more exciting studies coming because this comet is actually slowly coming closer to us. And by December, we'll have a lot more new studies that will probably explore other ideas as well. Let's finish this video by standing on the surface of this comet in Space Engine, and well, that's really it. If you've enjoyed this video, subscribe, maybe share this with someone who loves learning about space and sciences, and maybe even support this channel on Patreon because it does help me quite a lot. I'll see you tomorrow, space out, and as always, bye bye.